of you. I'm still jet lagged. If you can slightly decrease the light, it would be nice. Okay, probably not possible. Thank you for coming to this great ZenCon. What I'll be doing now is I'll present you things that you already saw in the keynote. Who wasn't in the keynote? Raise your hand. Okay, then it will be something new for you. But I'll go a bit further. So I'll show you also how you yourself can implement this. And we'll talk about a couple of things. So the topic is automation using Jenkins. So we'll see how we can implement continuous integration and continuous deployment. For the continuous integration stuff, probably you already know about. And for the deployment, you, I guess, heard today or no before that. Before I start with the real stuff, let me introduce myself. So my name is Slavoj Karadžov. It's probably the most difficult name to remember. You can see the Latin spelling and also the Cyrillic one, which is the original one. I'm senior consultant in Zen Technologies. I'm, as the slides say, a certified engineer for Zen Framework and PHP. I love programming, and it's not only PHP, but also other languages. I'm testing them, and after that, talking with the core PHP developers and asking them if they can implement nice features like generators from Python or other languages. And it seems like it's possible. 1 year after we talked with Dmitry, we have generators in PHP 5.5. I'm also the author of this nice book, brand new one. For those of you that would like to learn a bit more about Zen Framework, up there is the URL. Just go there and you'll get the information. So, how many of you here in the audience feel like developers? Raise your hands. You don't have to be a professional developer. Just feel like a developer, want to sit in front of the computer and program. Okay, and how many of you feel like system administrators, operation guys? Okay, so not so many.
The URL doesn't work.
Okay, I'll check it. Thank you for pointing this out. Yeah, has to. But you can go to Amazon, and inside there you can type learn ZF2. So this is another backup plan. Now, what is this talk about? We'll be talking about faster time to market, how we can deliver faster, why it's so important to deliver faster. We'll be talking about other things, so putting pressure on the developers and putting pressure on the operations and how we can somehow cooperate between these people. We'll be talking about automation, why it's useful, and the more interesting part for you who would like to work with tools and would like to build this thing together is I'll be talking about helpful tools that you can use and how we can put all the pieces together. I'll be brave and try a live demo. I'll be using also the wireless that you all use, so it may not work, but let's see. Now, this what I'll be talking about, and what is this talk about? This talk isn't about getting rid of the IT operations guy. That's what you can hear from executives or from the developers. I'm sorry, but it's not about this. And the other thing is, what usually the other side, the IT and the operations guys say, oh, the developers are so lazy, they produce so many errors, and it's us who takes the blame. So this talk is not about this and solving problems in that way. It's more about solving problems using some technology. So I'll start with faster time to market. Now, what is this and why it's so important? Well, if we have a great product, but we delivered 10 days after our competitor, then it's a bad luck because all the media went to our competitor. So it's quite important to release your great product and not keep it in-house as soon as possible, and also to put more features. Why? Well, probably it's in the nature of the human to always want something new. a little bit too early, a little bit too shiny, but something new. And Facebook is using this. It's releasing a lot of new features, a lot of new stuff, and you can see it probably not every day, but every week. And that's also one of the reasons why the people increase and why the people use this. Now, this is how you can attract new guys to your website, but there are other things that can keep them. And the other things are you need to have improved source code. You need to have improved quality. And there are ways how we can achieve the both of two worlds. So release faster new features, but also have some good quality. So what we want and what we'll be talking about is here at the bottom, deliver faster, more features, better quality. So how is this done? Long ago, people started to ask themselves how we can do this. They were mostly dealing with models like the waterfall model, where you produce for 1 year your application, and by the time you make it public, it's so outdated that nobody uses it, or the customer is pissed off because he wasn't able to see for 1 year what's going on. And then new ideas came for the development world, which you all know, I guess, about Agile development. I wrote here some SCRUM, extreme programming, Kanban, or I guess there are thousands of things that can make you work faster. But the main idea is you don't wait till 1 year passes. You try to limit yourself to some small short cycles. For example, a week, 2 weeks time should be enough. In that time, you try to implement features that are important, and that should work at the end of this cycle. You don't implement something that can span over more time. And then you have the possibility to design it, develop it, test it, and release it relatively fast. So that's what the development side had in order to help them speed up development. For the quality, we have the unit test, and for the PHP world, you know, PHP unit is king for the moment, and probably will be, because it gives us all the needed functionality for automatic testing of our stuff. Now, if you program, and if you have one server where you deploy application, everything is fine and sexy. So you have your Agile deployment, you deploy the application on one server, the overhead is not so big. If something goes wrong, the IT guy knows how to handle one server. But in our modern world, we have more than one server serving an application. So maybe some of you already have like 3, 4 more servers serving an application. Raise your hands if you have. Okay. Whoa, quite a lot of people. And then you need additional effort in order to be able to push these new changes fast in a secure way. What means a secure way? It means reproducible and also being able to revert if something happens. And then you need to put some additional effort, either in creating chef scripts or using already existing solutions or trying something from your partner companies. And then comes the moment where we start talking about cooperation between devs and ops. So the cooperation between devs and ops is just a methodology, which helps you to make the communication between the two parties more easy. Why it was so difficult? Well, because in big companies, I'm not talking about startups, usually the two departments are strictly separated. And they are working against each other because the developers say we are working fast, but our features are never released on time. The IT guys say, yeah, you're working fast, but you're producing such a lousy code that we have to test, fix, and it takes time, and it never works. One of the things that, so this is true to some extent. One of the main reasons why this is happening is you produced your source code, and it works perfectly fine on your machine, but you forgot to tell the op guys that you need this module dependency on that application, this specific PHP INI settings, and so on. and maybe you were forced to describe them in a document, but by the time after 2 weeks, when you committed your change and went for evaluation, it was already outdated. So that's why the DevOps movement, so to say, was born, and it was trying to fill the gap and improve the collaboration. But now we are coming to the continuous part. So what most of you as developers know is continuous integration. The continuous integration is helping the developers to implement fast development cycles. So obviously, if you are limited to 2 weeks, then you don't have the time to manually test. Or there are some time-consuming tedious tasks that can be automated and that are repeatable. So what you need to do is you need to create unit tests for only the features that you're producing. Then in order to have some, to keep a good quality, I'll say coding styles is something important, detection of copy and paste metrics and so on stuff that allows you to have an insight about what happened in this 2 weeks period. And using continuous integration, it was possible to do this. And now comes the next step. So continuous integration is more for developers. Now comes the continuous delivery, which is more for the operations part. And it's natural extension of continuous integration. And you don't have to read all sentences here, just the red one. So continuous delivery is about every change is releasable at the push of a button. That's what you have to achieve. And if you're able to achieve this, then you'll get a fast feedback from the users. And you know if your feature was what they were expecting. You know if the feature is working well. And that's usually something very good for the business. Okay, I'm starting to go a bit more into details, and I'll show you this graphic. So the continuous delivery process is a bit slightly complicated. What you have is, if you want to have reproducible results, so first you need to get the source code from some central repository. Most of the common problems that existed once upon a time was when the developer says it works on my machine, he forgot to commit a specific file, and it worked on his machine, yeah, we agree, but on the production server it didn't work at all. So you're committing to a version control, then what you need to do is you need to run some unit tests to see if this is happening. If it's not working, then the developers need to fix the stuff. And if it's working, then we go to the next step, which is some automated acceptance tests. And if everything works fine, it's a very good idea to test with real people. So then we need something like a staging system or testing system where the real people, preferably no developers, just users, start to test the system if it's working. And then, if everything is fine, using this same source code that you were testing and deploy it on production and have the final version. So if I use the sequence diagram and turn it into something like, I'll show you in a second. So what we'll try to do, or I'll try to show you, is how we can implement all that parts. 5 years ago, maybe it was difficult. It was requiring some effort from your side. Nowadays, it's just putting the pieces together, knowing which software you can use, how to use it, and I guess after the talk, most of you will have this implemented already in their companies. So automation. Automation is another keyword that we'll be using here when you talk about continuous delivery and continuous integration. And automation is king. Why? I gave a couple of reasons. So first, for me, the most important thing is that it gives deterministic results. It means that every time when you run it, it gives you the same result. If it's bad, it will be bad the next time. If you're using a human, if human is involved, then you don't know what's going on. another thing, with automation, you're able to reproduce faster time-consuming tasks. And if you use a system, continuous integration system that allows you to automate some of the things, then you'll be able to automate all the steps just with a click of a button, and that's our final goal. So we have an application, we created a new version, we'd like to test this. If the tests are running successfully, we'd like to have it on our testing system. If the tester says that everything looks great and works fine, then we'd like to have this same source code deployed onto staging or production, depending how many steps we have, and to make this as fast as possible. Why? Well, because if you spend 1 hour installing the new software on one machine, then trust me that installing this same software on 20 machines won't be 20 hours. It will be much more if it's one person. And if there are two, the time will be even bigger, because the more people we have, the more chaos you introduce to the system. And the final result is bigger than the sums of the two chaoses. Okay, so that's what I was showing you about the automation, and that's what we'll be using in order to achieve it. So what I have here is, I have here the developers, 1 to n developers, that will be committing their changes. They'll be putting them into Git repository. So it can be any versioning system. I decided to go for Git, but if you're using Subversion or something else, Mercurial, it's also fine. Then I'll show you how we can build continuous integration server, which will get this source code, which is into the Git repository, and then it will try to do something. It will try to run unit tests, it will try to package our software, and it will try to deploy it on some machine. Because what we want to achieve is, we want to achieve application which is deployable and with relatively good quality. So what I'll do now is I'll present you the solution like a cooking recipe. So we have some ingredients, we need to do something, at the end we need to stir and to cook for a couple of minutes, and the final result will be there. In order to achieve this, so you need 1 to n Zen servers. And also you need 1, you can have more, but 1 is enough, continuous delivery server with Jenkins. Jenkins is not the only continuous integration system. You can use Bamboo, whatever. Just for simplicity, I didn't want to show you all the possibilities. I wanted to show you one option, and then you can implement this one to your actual system. Then we have a period of preparation. Once we have the main ingredients, we'll do something in specific files that have to be added to our project, our PHP project. We're talking about only 3 files in here. And then we need to do a small configuration in Jenkins, mainly enable 2 modules. And then the rest is putting the pieces together. So probably your main concern will be the 3 files over there. I'll show you how the files are looking. And if you already dealt with Ant, Maven, Phing, or other build system, then it's quite easy to understand what's going on. So, and then once we have everything prepared, we will try, before pushing the button, to do this getting of the source code from the repository, to run Phing with deployment target, and see if our application is deployed on the server. We want to achieve deployment not on only one server, but we want to achieve deployment on all machines in the cluster. So when I say server, I mean 1 to n machines, where n can be, let's say, 100. Who has the biggest cluster here? I didn't ask you how many machines you have in the cluster. Who thinks he has the biggest? 25. 25? Somebody more? 240? Somebody more? Okay, so we'll stick with 240 as number of machines. Okay, so first, we need to install Zen servers. The instructions here are for Debian-based system. You can use this, or you can easily figure out how to install the same software also on Red Hat, Windows, Mac, or any of the systems where which is supported by Zen server. So the first thing that you need to do is you need to execute this command, nothing more than adding the Zen repository to the list of package repositories. And then you need to update and you need to install the software. So far, so good. That's, you can use a chef recipe, whatever, if you want to automate also this part, and then you're ready to go. Now, we need one continuous delivery server. For this one, we need PHP, because we'll be making some tests in PHP. And then we need also pair that will help us with installing the next software. We need PHP unit for the PHP unit tests, and we need a bit more. So these are just simple commands that you can execute on your command line. So then we need phing. Phing is our build system. Maybe you know C, you're familiar with make, something like this, but allowing you to do more things, and you have to stick to describing them in XML file. So, and once we have the PHP stack with the PHP tools that can help us test our project, we need the main piece, which is Jenkins. It's automation system which is not PHP specific. It's actually nowadays not even Java specific. It can allow you to automate a lot of things for different computer languages. There is enough support, also thanks to probably some of you who are here in the audience. Okay. Now, there is a small piece. This is like the secret piece that you put in the recipe to make it really tasty. And this is 2 megabyte PHP far file that we need in order to be able to control the Zen servers. So what we need is we need to get this PHP tool, and if you're familiar with Zen server has a web API. The web API allows us to control most of the functionality remotely using this specific client. It allows us, what we'll be more interested in is it allows us to deploy packages remotely. It allows us to restart the servers if that's needed. It allows us to change the configuration. Everything can be done remotely. And if you're using Zen server, which we'll be using, if you make this change on one of the servers in the cluster, then it will be automatically replicated on all the others. Okay, now we have the software, we downloaded it and install it. Then what we need to do is we need to prepare our PHP application to be able to be deployable and testable. So you can use any PHP application. You can use actually any application which has some files. What you need to do is you need to put into the main folder of this application 2 files, deployment XML and deployment properties. So if you have Zen Studio, then you don't need to know about these files. How do they look like? If you don't have Zen Studio, then you can use again this ZS client far file. You just need to say init.zpk into the folder where your source code is stored, and these files will be created for you. What the deployment XML contains, it contains information about the version of the application. It contains information about the requirements of the application. Maybe you are requiring some specific library. Maybe you are requiring some specific settings in the PHP, some of the modules, directives. And the deployment property says which files from the source tree should be included. Usually you don't include the documentation and deploy it on the production server. You don't include also some other testing stuff that you have in your source tree. Then what you need is you need the build XML file, and the build XML file describes the steps that are needed. So in the build XML, you specify what you have. In my example one, which is located on the link below, there is running unit test. After that, we need to package the whole thing into one zip file, so to speak, if I want to simplify it, and then we deploy it on all the servers. And the most important thing here is we need to make a small preparation. So I told you that we need to test this source code, and we need to be sure that the same source code that we tested is already deployed on the production system. That's a very important thing. And history is telling us that this is quite often forgotten. If you look at the history of the space shuttles or the satellites, feature added in the last second manually was causing the shuttle to explode. So that's something that we don't want. We want to test one thing and after that deploy it to production. How this can be done? Well, in the deployment XML, what you can do is, I'll try to show it after that in the demo. You can specify different parameters that the user, so to speak, can answer when he answers the application, and in there you can specify what is the targeted environment. So I can say this is a package for my testing environment, and then the Zen deployment mechanism allows you to get the answer and yourself to do some control over it. Finally, what we need to do is we need to configure our Jenkins. That's, once you have installed it, that's relatively easy. Jenkins provides a web interface, so you'll be mainly working with a web interface. You need to go to manage Jenkins, to the plugin manager, then you have to see what plugins are available, and you have to enable Git and phing. They're coming by default with, at least with the Debian and Ubuntu installation. I guess that's the case also for the other operating systems. What we'll do with these things is we'll use them in our project, and we'll try to specify some settings for them. Okay, so if we're ready with this, then we can go to the final step. And the final step is relatively easy. We need to say, I'd like to create a new Jenkins job. We can do it from the Jenkins web interface. And there are a couple of steps. The first step is, major step is getting the source code. So Jenkins comes by default with support from Git, Subversion, SVS, and so on. And you just need to provide the URL. And what I find important is you have to specify which branch you want. This talk is not about telling you how to branch your versions. There are quite good talks on the internet, but maybe you can tell me how you're doing. Do you have like a production branch and all the data that goes into the production branch is deployed? Okay. Somebody having another mechanism? I've seen people just putting it to master and then trying to deploy this. I'll say go for a separate branch, because this way you can also, during the week, you can cherry pick if there are new features already done. You can cherry pick from the master branch, put it into the production branch, and then test if everything is deployable. So another thing with Jenkins that you have to specify here is, and this is more Git specific thing, you have to specify who is the user and the email of the user. That is needed. For one thing, once you get the source code and everything is working fine, you can internally tag this source code. So even if you lose your package, something happens, the tag will show you exactly which source code was used for testing this. And that's helpful to figure out also our problems. So if you know I deployed version number 1.1, the tag for this one was this, then later on you can, there are a lot of good browsers for the differences. You can see exactly what source code was deployed compared to the previous version. And you can use this to figure out a problem. Okay, now we have the Git integration. Then the next thing is we need to use phing, the build system. For the phing, what we need to do is we need to specify the target. Here I'll be using deploy as a target. And then you need to specify parameters. I mentioned about the web API from the server. In order for this web API to work, and in order for you as a client to be able to access it, you need some credentials. And the credentials are given here in the key of the web API and the secret part. So that's something that you need to provide. The next thing that you need to provide is also where is the server located. So it doesn't need to be on the local machine. And additional parameters when you deploy an application. So that's everything that you need. You can go also one step after that. Jenkins allows you, if you have a successful build, to have some post-build tasks. For example, email the boss that it worked, or email somebody else. And then immediately after having this successful build, somebody will be informed, and this information, the process will continue. So what I'll try to do now is I'll try to demonstrate you a bit the things that I was talking about, and to show you how easy or difficult it is to have that stuff running. And again, disclaimer, I'm using the open Wi-Fi, and I'm getting some stuff from internet, so hopefully it will work. Let's see. Okay. So what I have here is I already have Jenkins installation, and I have something which I call project, but in Jenkins terms is project and job at the same time. And I'll show you the configuration here. So for the configuration, you need unique name, okay? Then what I'm usually doing is I'm not keeping all the builds that were executed, but I'm keeping some builds. In this virtual machine, just the last 3 ones. Then I'm specifying in here what is the Git version, the Git repository URL that I'll be using, what is the stuff that you want, and in here, in the advanced section, be sure to check these 2 parameters. If you don't check them, then Git will give you a strange message saying that you didn't set them, and you can try to set them somewhere in the bash, but it will not work. Okay, once you're ready with this, you come to the build phase. You'll be given here different options, which system do you want to use for building, and even you have to specify a thing. Then you need to specify what with the deployment target. I'll go in a second and show you what I'm talking about. And then you need to specify the parameters. So I don't have post-build actions, but you can quite easily add email notification if it's needed. So that's how easy or difficult it is to describe such a project. And then in order to build it and to have all the steps, you just need to click on the Build Now button. So that's what I'll do. And let's see if this will work. So it tries to get the source code for me. I have hopefully some information. Okay, so I was able to deploy the application on all of my servers. What it did is it get the source code, it provided some parameters, it ran the unit tests, all of them successful, it created the ZPK, it created the deploy part. Now, I would like to show you how this was done, how Jenkins knows that it has to run unit tests, how it knows that it needs to run packaging and so on. So the file that is important is the build.xml file here. You can name it also in another way, but then you have to specify in Jenkins exactly what is this, the name of the file. I'll go for the standard stuff. So the build.xml, we have description saying us we have unit tests. For the unit test, we need to run this part. We have target code ZPK for this one. First, we need to run the unit tests, and then we run this external command. And finally, we make our deployment. So in here, you can see how also the parameters are passed to the from Jenkins to phing. This was one of the pieces. The other piece is the deployment XML file. I'll show you what it contains, not so much of information, just provide some information about the name of the application directory, the scripts, and that's it. Then the deployment properties. Maybe I can try something like this. So let's see if this will work. It's just a file containing the properties of containing the files that need to be included in the application and the files that need to be included in this scripts directory. So if you know about deployment, that's everything that should that is needed to have a releasable source code. Now I have here a repository which contains all the source code. So later on you can check and see if see the build.xml, for example, or the other parts. At the end of the presentation, I have this link, so you don't need to remember it right now. And I'll try to show you also how my application is deployed on the cluster. Excuse me. So I have here a virtual machine, actually two virtual machines. One of them running 3 Zen servers in a cluster. Here's the application. And I'll try to keep this on top. Doesn't work. And I'll click on the deploy button just to see if this will be deployed on all the servers. So here, if you go to administration, you can see the servers. So I have 3 nodes at the moment. Okay, so if everything goes fine, then I just need to click on the Build Now button. And then in here, there should be something happening. So it started to activate, it deployed the application on the 3 servers, and I'm done. So that's everything. It's for projects up to 100 megabytes, it's saving days of work. Okay, now I'll switch to Zen Studio and I'll try to show you something more here. If you have Zen Studio, you can directly work with this deployment XML. And now it doesn't look like an XML file, it looks more like something that you can play with. And here, the thing that I was talking about is if you go to triggers, inside here you can specify different parameters. Let's see if I can make it bigger. So here you have the possibility to add variables or parameters. I have already a parameter. I specified the unique ID of this parameter, of that parameter. And I'm specifying here the available options. So I have a testing, staging, and production environment, and by default, if I don't answer a question, I'd like the testing to be used. Okay, this is just asking the user to provide some input. It can be automatically provided. Now, this doesn't mean that my source code automatically will know on which application environment it's deployed. And there is another thing in Zen Server. It's called trigger scripts that help you to control different phases. So we have a staging phase, activation phase, and other phases down there, which will allow you to add additional PHP logic. So I have here a post stage script, which is trying to read what is the current application environment, and then based on this, trying to get the configuration file, and after that decide which, for example, which database connection to use, which files to create, and so on. So these are all the things that you need to do in order to prepare yourself for such a deployment. Now, I have some time. What I'll do is I'll show you something more. Deploying an application is something great as long as the application also works on the production server. But if it doesn't work, then we're in trouble. And here, in Zen Server, what you can do is you can just roll back to the previous version. So if this version wasn't successful for some reason, it's causing a lot of trouble on my system, I can just roll back, and the rollback will go on all the servers. So I'm done, and that's everything that I need to do, nothing more. Finally, if I want to have another server added to the cluster, then I have to do zero work. Why? Because Zen Server is taking care of this. If you add another machine to the cluster, it will try to deploy your application also there. It will try to sync the configuration with the configuration of the cluster, and you're good to go. So that's how you can, one of the suggestions for continuous delivery. Okay, then that's what I wanted to say to you for today. Here's some useful links if you want to rate the session, the first link. If you want to take a look at the ZS client is the second link, and the demo application on the third link. We have time, and I usually like to see some questions from the audience. Any questions related to continuous delivery to some parts? Yes. You're right. So, does it, yep. Good question. So there are a lot of possibilities. One of them is you can use, for phing there is already a target which is taking care for implementing database migrations based on Liquibase. So if you're familiar with Liquibase, Liquibase allows you to check between releases what was the structure of the database, and if there is a difference, it puts it into a XML file, and then these differences are deployed on the server and applied in there. Now, the Liquibase requires also to have Java. What I'll say is, and what I've seen most of the customers using is they use doctrine migration. So you can go for this way if you want. And the final poor man's way to do it is somebody, maybe you, have to manually describe the changes and to have a good structure. So Zen Server itself doesn't provide you any extra utilities here. You have to code it yourself. For every version, you have to specify the change which is there, plus the reverse, if it's not so easy for database system to figure out what is the rollback. Okay? Some other questions? How many of you implemented already Jenkins and Zen server and on their system? Okay, 1, good. 2? How many of you plan to do this? How many of you okay, big number. Okay, this saves time. So, okay, in the beginning you have to invest some time, but after that it really saves a lot of trouble. And neither the ops guy, neither the dev guy has an excuse that something is not in the workflow working as expected. Okay, thank you again, and enjoy the conference.